We did notice in the early 2000s to late 2000s that there was a lot of dead trees out there. It had been a gradual process, and it may have been happening since the 1990s, even possibly the 1980s. But by the 2000s, there was a lot of dead trees.
I had been travelling down into the Snowy Mountains for annually or more, several times a year for probably the last 20, 25 years. And I had also noticed trees looking really unhealthy and then trees dying.
I was just absolutely flabbergasted at how extraordinary and how widespread and how almost every tree had diminished or was dead.
I guess it's 15, 20 years now. At least is a sense of sadness that the remaining rare trees in some of our grassy woodlands are starting to look like a cemetery.
I've been a botanical artist for a few years now. I live in a place called Burra, which is just north of Cooma, and periodically I drive through the Monaro. I'd see dead trees there. I didn't think anything about it. There was one particular tree that caught my attention. I thought it'd be absolutely wonderful to be able to do a drawing of this or a painting of this dead tree. As I continued to drive through the area, I realised that there were more and more dead trees. It's not normal. I mean, it's not right. You just don't see that. You see an occasional dead tree. But then my eyes were seeing, tree after tree after tree, great areas of dead and dying trees. And, it was starting to concern me. And, I'd stop my car and I'd get out and go for a walk through these areas. And it just gave me shivers. It was really a powerful response to all these dead trees. And that started me wondering, why? Because they're obviously eucalypts. There hadn't been a fire through the area. I couldn't understand why there were all these dead trees. So I started doing a little bit of research and discovered something called dieback.
I did my honours research back in 2012, 2013 on the eucalyptus dieback that started on the Monaro. Nobody really had any idea what was causing it, even which species were affected, what could possibly be happening.
And when we started looking at it in detail, it looked like it was one species, Eucalyptus viminalis, the ribbon gum or the Manna gum, and it was just disappearing en masse. So wherever you saw a dead tree, it was a viminalis, and whenever you saw a viminalis, it was dead.
I was really interested in the complexity of the problem, that it was such a mystery and nobody had really looked at it before. I'm the kind of person that likes a complex problem and I like lots of interacting factors. It did make it too big a project for an honours, really, and I wasn't able to solve the problem in a year. Dieback doesn't really say anything about what's causing it. Dieback is just a very general term that describes this slow decline of trees, but usually there's this kind of progression that happens with some kind of stressing factor that makes the trees more susceptible to insect attack. The Monaro is very dry already, being in a rain shadow, and the ribbon gums are right on the edge of their range in that location. So with that warming and drying that's been going on, that may have pushed that species beyond some threshold that they can't deal with anymore.
The Monaro is it's a hard climate. The ribbon gum there is at the driest edge of its range in a very cold environment, so it is quite extreme. There was droughts in the mid-2000s, and then we had rainy years, 2010, 11, 12, but there was no response from the trees, so they just kept dying.
A lot of the episodes of dieback that have happened in Australia, there's been an insect involved. So there was a weevil called the eucalyptus weevil that's a native species in Eastern Australia, but it had never caused any kind of dieback issues before. The question was working out why this insect species was having this outbreak at this time. And I looked into a few different causes to do with farming practices, fire regimes, and nothing really stood out as the cause. It didn't explain the patterns that we were seeing.
It's almost impossible to find a eucalypt without anything eating its leaves. So the Australian insect populations in particular are adapted to eat eucalypt leaves, but then again the eucalypts are also adapted to fight them off. So when a tree is denuded, something's gone wrong in that balance.
The insects come in and strip the canopy of the trees. Most eucalyptus species have this strategy where they put out epicormic growth, which is what you see after bushfires. When a tree's lost its canopy, it just puts out a whole lot of growth from the trunk and the branches just to try and replace that canopy. But that new foliage is really palatable to insects. So once you've got this feedback started, it's really hard to stop, and the insects just keep attacking and attacking, stripping the tree every time it tries to recover.
They lose their leaves, they spread the epicormics out, the weevils eat the epicormics, you get more weevils, eat the epicormics, the tree tries again, and you get downward cycle until eventually the tree runs out of stores, its own nutrients, and dies.
It's an ecosystem collapse, what we're witnessing. The death of the dominant tree species across the landscape has literally turned a woodland into a grassland in a few short years, with all the associated effects on the biodiversity, the landholders, their stock, the general health of the landscape in terms of water cycle, nutrient cycling, even the climate. You now got vast, windy, windswept, freezing plains, whereas you previously had at least woodlands to buffer a bit of that. So it really is a huge environmental catastrophe for the region.
Most of the trees out there are dead now, and no chance of recovery, which is really sad.
First of all, dieback is slow and insidious. Doesn't all happen in one go. And then maybe after you've been going through this district for 10 or 15 years, you suddenly notice, well, most of the trees are dead there where we drive along that main highway to Berridup.
This is sort of one of the first really obvious cases where climate change has caused this kind of ecosystem collapse, and nobody was really talking about it. It just seemed bizarre to me that this could be happening right in front of people, and they'd just kind of shrug it off and go, oh well, trees die all the time, it's staring at people right in the face, and they just walk right past.
There's enough information now, 100-fold around the planet, to tell us that we're heading for disaster. We're just not acting fast enough, and the majority of us are ignoring it.
We don't see gradual change. And I think that's a real big problem with a lot of environmental management, is that this started, we don't even know when it started, because it's common to see a dead tree, really common. It's common to see a bit of dead wood in the canopy of a eucalypt. But when it starts to get a little bit more, when there's 3 or 4 dead trees or a lot of dead wood, but it happens slowly.
We're so used to seeing change that happens in a matter of days or weeks or months, but when we're talking about decades or centuries, we just can't conceptualise that.
There's increasing talk about the fact that our species, Homo sapiens sapiens, meant to be doubly wise, have pushed the Earth into a whole new era. The previous 12,000 years to where we are now was called the Holocene, and it was that unique period when humans developed agriculture by domesticating plants and animals. Since then, the activity of one species, we humans, with industrialisation and the takeoff after the Second World War, is now setting up for disaster the way this planet functions. Therefore, that whole new era, post the Second World War, is called the Anthropocene, a human-caused new geological epoch on Earth that we've never seen before. Some of the ecologists I work with, particularly those that work with the regenerative grazing approach, classify landscapes on a brittleness scale. So the really rich, lush, diverse, quite predictable rainfall areas are non-brittle, down to sort of deserts or semi-arid areas, which you'd say are brittle. So I would put us well onto the brittle scale, which means it has to be handled very carefully. Our basalt country here is largely naturally treeless, and the metamorphic country up high is very thick, mainly peppermint. But it's the granite, grassy woodlands in between, which is A, where the dieback is, but B, so it was easily cleared. And did they clear it? They cleared nearly all of it here.
In fact, there was a requirement to take out your trees if you were provided a block or if you purchased country.
Once it was cleared, it was definitely overgrazed. You get compaction of the soil, you're losing a lot of your native grass and other species. You've got less penetration of rainfall and less healthy soil conditions, and all those issues start to bear.
That human impact will have had a huge amount of responsibility around what's gone on and why this landscape, it'll have a dieback episode.
I taught a case study on the New England dieback, eucalypt dieback. The coup de grace to the trees was really an overpopulation of Christmas beetles and fostered by a healthy soil environment for scarabs. But when you analyse the case, it was sort of 20 different factors, and it was a progressive pulling out the rungs of that ecosystem until it went. So overclearing of trees was the obvious one, which applies here. Superphosphate fertiliser that fosters conditions in the soil for the scarabs. And the overclearing not just of trees but the diverse shrubs. So you got rid of things like blackthorn, which sustains parasitic wasps and other insects, which we have here, and they play the same role. And the wattles, which are food for the sugar gliders. One of the major predators of Christmas beetles. A sugar glider will eat its own body weight in one summer night when it's on. So eventually the whole thing went when it got too simplified.
This is almost the underpinning story of ecology is diversity. Something in every niche, something ready to move into every niche.
Bettongs are what's known as ecosystem engineers. They dig for food, tubers, insects, under the ground, and they create these little pits that provide sites for seedlings to germinate. Before bettongs went locally extinct, they would have been turning over this soil at a huge rate and providing these little pockets for seedlings to germinate. The trees that we see around us, you know, they probably germinated in bettong diggings. So when we think about the changes that have happened to these landscapes over the last 100, 150 years, we've lost these species that are doing this crucial ecosystem building. And then, you know, we've brought in all of these other issues with the way that we manage land, and they've all worked together to result in these declining landscapes. And what we're seeing now with huge dieback episodes is probably the culmination of all of those things that we've been doing. So it's not just one single factor, it's a mixture of all of these things that we've done over time.
If we really consciously want to preserve this tree landscape, we're going to have to manage it quite differently. The Monaro is going to get hotter, probably more droughts, more dieback occurring. And because that resilience of that landscape is less, I can only see the situation worsening, particularly if we don't start going about trying to restore the grassy woodland areas back to a more diverse state of health. We have to get that functionality back, and you can only do that by trying to replicate that diverse suite of species that were there. And we're talking about 25, 30 trees, shrubs, small plants. If we don't get into it pretty soon, it's going to keep collapsing and become less productive and less profitable to survive in.
In 2015, one of my colleagues here, Bindi Van Zeller, pulled together a whole lot of stakeholders on the Monaro and put in a funding bid to the New South Wales Environmental Trust for 6 years of funding to try and start to address the issue of dieback on the Monaro. When I started the project, it just seemed enormous. It seemed insurmountable, really, the extent of the dieback. Yeah, it's truly shocking in some of the worst places. It's just hard to believe that all of those trees have died, and it's not due to fire or other effects like that.
I first saw the advertisement for a position for 50 days. So the Landcare group had 50 days of funding to do something around the issue, and that's not a lot.
We're still not a lot closer to understanding the ultimate causes.
You get to a position where you have to actually just sort of give up on that whole idea of really getting to the bottom of it, because it's got so many aspects to it.
Research into these sorts of things is complex and it takes a long time. In the meantime, what we've been doing is trying to restore habitat.
We started taking up some grant opportunities, so we wrote grants around this situation and looking at putting biodiversity plots back in the space where the trees had been taken out. That started to really get some energy going around it, and in fact that's what we're still doing today. So in the absence of having an absolute reason for what we're doing, we just thought, let's put something back in the ground that's a mix of native plants that can, at least in some point in time, give some species some respite and hopefully save some if there's some just lingering There's a lot of native animals that use these trees. They're a huge resource. They're a habitat tree, and so we've been putting habitat plots back in that area.
We're trying to establish these sort of future-proof biodiverse plots. We're trying to find something that's going to be a little bit more resilient to a future that we have predictions for, but we don't even really know how accurate they will be. And if we don't start now, we'll never know. We'll arrive at the future and we've got nothing.